I am Anil Kumar. Welcome to my series on exponential equations. We're actually doing exam review, and here is a test question from GCSE test paper, Cambridge International AS and A Level Mathematics, 9709 paper 21, question 5, November 2014. The question here is, given that x plus 2 and x plus 3 are factors of 5x cubed plus ax squared plus b, find the constants a and b. When a and b have these values, factorize 5x cubed plus ax squared plus b completely, and hence solve the equation 5 to the power of 3p plus 1 plus a 5 to the power of 2p plus b, giving any answer correct to three significant figures. So you can pause the video, answer this question, and then look into my suggestions. Now, the very first thing which you notice here is that GCSE examination questions normally involve more than one concept. So we need to begin with polynomials in this particular case, do division to get the values of a and b, since we are given two factors and a cubic equation there, right? Once we find the equation, we get the parameters a and b. Then we have to solve the exponential equation. So it's kind of very interesting. However, they have also shown you steps to solve the final equation. So I hope you are understanding the strategy of how to prepare for this particular test. And I'm keeping that in my mind while sharing with you my series on exponential equations exam review. Correct? So now let's look into this question once again. What we are given here is that two factors are given to us and the equation is given to us. So the equation is 5x cubed plus ax squared plus b. And we're given two factors, which is x plus 2 and x plus 3. So when you multiply, you obviously get quadratic equation, not cubic equation, right? That means one factor is missing. So we have to find another factor here which is missing. So that factor we need to figure out. How are you going to find this out? Before that, we have to find the value of a and b, and that is what the question says. Find the constants a and b. So this is your first step. So that is what I mean when I say that they help you laying down the steps to follow so that you could come to the right solution. Now, when I say that x plus 2 is a factor, it means what? X plus 2 is a factor. It means that if I substitute in my function the value minus 2, I should get a 0. Correct? Similarly, when we say that x plus 3 is a factor, in that case, the value of f of minus 3 should be equal to 0, where the given function is 5x cubed plus ax squared plus b. You get the idea, correct? Using this concept, we'll get two equations, two unknowns. We can solve for a and b. And that is our first step. Let's see how to do it. So we are saying that the function here is, let's say f of x is given to us as 5x cubed plus ax squared plus b. Now factor is x plus 2. That means the value of the function at x equals to minus 2, which we could write as f of minus 2, which is 5 minus 2 cubed plus a minus 2 square plus b, that should be equal to 0. So now you can solve it. 8, right? So you get 5 times minus 8, and this is plus 4a plus b equals to 0. And now you can say that you can simplify this and write 4a plus b, bringing this to the right side is equal to 40. So we get one of our equations. Now, the other factor is x plus 3. So these are the two factors. We have already made one equation from the first factor. Now we will see how to use the second factor. So f of minus 3 is also 0. So 5 times minus 3 cube plus a times minus 3 square plus b is also equal to 0. Minus 3 cube is 27 with a negative sign. So 5 times minus 27 plus 9a plus b is equal to 0. So that gives you 9a plus b equals to 5 times 27. So you can multiply 5 with 27 and then get your equation. 5 times 7 is 35, 3. 5 times 2 is 10, so you get 135. So we have two equations now, correct? So let me label the second one as our equation number 2. Now from these two equations, if I do equation 2, take away equation 1, what do I get? 9a take away 4a is 5a, and b minus b is 0, that is why I did it. We get 135 minus 40. So that is 5a is equal to 595, right? So a is equal to 95 divided by 5, which is what? 1, and then you get 45, so 19. So we get the value of a, let's call this as equation 3, as 19. So we've got one of the values. A is 19 for us. Now let's continue to find the value of b. You could use one of our equations, let's say equation number 1, to find the value of b. So from here, we can say b is equal to 40 minus 4 times a, which means it is 40 take away 4 times 19. And that should give you what? 40 minus 9 times 4 is 36, 376, right? So that gives you the answer as negative, and this is 36. So B is negative 36. Perfect. So at the end, you get the value of A and B. Now you know that the A value is 19 and B is minus 36. So we have done part A where we needed to find the values for A and B, right? So these are my values for A and B. Now let's continue and do the next part. So we got A as 19, B as minus 36. So let me write down these values here. So we'll have A as 19 and B as minus 36. Okay. Now the question is that we are given all that. We are doing now part B. Okay, so this is done. This is part B for us. Okay. When a and b have these values, factorize 5x cubed plus ax squared plus b completely and hence solve this equation. So we need to factorize the cubic equation. Okay. So let's try to factorize the cubic equation. So which is now 5x cubed. A value is 19, so we can write this as plus 19x squared, okay, and b value is minus 36. So we need to factorize this. Let me write this as a function f of x. We already know two factors, which is x plus 2 times x plus 3. Third factor we need to figure out. So when you multiply, you get x squared, and you add these two, sum is 5, and the product is 6. So you get your equation. So let us divide to get the third factor. We could do synthetic division or the long division. Most students are familiar with the long division, so we'll do the long division. Now here we have 5x cubed plus 19x squared. X term is missing, so we'll put the placeholder 0x minus 36. And we have to divide this by x squared plus 5x plus 6. So we get x here. Well, we could not have done synthetic division because you're dividing by quadratic, right? Normally, synthetic division is done when you divide by a linear factor. Okay, so this is the only choice. Multiplying by 5x will take care of 5x cubed. So we get 5x cubed plus, here we have, what is this? 5x, right? So 5 times 5 is 25, x squared plus 30. So when you take away, the first term goes, and here you get negative, and 25 minus 19 is 6, x squared. This becomes minus 30x, bring down minus 36. Now it'll go 6 times negative. So we get negative 6x squared minus 30x plus minus 36, all negative. And what you get here is 0 as the remainder. So now you know that the third factor is 5x minus 6, correct? So that is how we got the third factor, which is 5x minus 6. So we can now write down that our quadratic equation given to us, rather the cubic equation, which is 5x cubed plus 19x squared minus 36 is in fact equal to x plus 2 times x plus 3 times 5x plus 6 minus 6. Okay, so that is the equation, and these are the three factors. Now the question is, when a and b have these values, completely factorize this equation, which you've done, and hence solve the exponential equation. We have to now solve the exponential equation, which is 5 to the power of 3p plus 1 plus a times 5 to the power of 2p plus b. So let's do it in the next page. Remember, we got the third factor as 5x minus 6. Okay, so let's move on. So we will write the factors, which is 5x minus 6 is the third factor. The first two being x plus 2 and x plus 3 given to us, right? And that is equal to the cubic equation, which was 5x cubed plus, let's see what it was. A and B values were 19 and 36. Minus 36. Yeah. So that is what we have. So this is what we've done so far. Now let's look into part B, which is when A and B have these values, right? So we know what A and B are. So the values for A and B are, let's write down. A equals to 90 and B equals to minus 36. Factorize 5x cubed plus a x squared plus b completely and hence solve the given equations. So the equation which we need to now solve is 5 to the power of 3p plus 1 plus a times 5 to the power of 2p plus b, right? This is what we need to factorize. Well, I could write this as 5 to the power of 3p, and the term that gives me additional factor of 5, right? So that is how we could write exponent 3p plus 1. And then we have a, 5 to the power of 2p plus b. Now this equation is actually similar to the equation which we just factored. And therefore, we could factor it in a similar fashion, correct? So if I make a substitution that, let us say if I say that 5 to the power of p is equal to x, in that case, we get the same equation, right? So um, we could actually solve this using x as 5 to the power of p. And that means we could write this as, instead of x, I'm going to write 5 to the power of p, right? So we have 5 times 5 to the power of p minus 6 as my first factor, and 5 to the power of p plus 2 as my second factor, and 5 to the power of p plus 3 as my third factor. You get the idea. So these are the three factors. Now when you say solve this equation, we have to equate this to 0. Now remember, 5 to the power of p is x, so in this case, we know that 5 to the power of p is greater than 0. It could be 0 also. No, the exponential function is never 0, right? It is greater than 0. That is the output. So it has to be greater than 0. Now, different answers each factor will give you. These two are giving you negative answers, so that is not a point, not valid, right? So we say this is not valid. So the only solution valid is here, which says 5 to the power of p is equal to 6 over 5. Correct? So this is the only valid answer which we have for now, because that gives you a positive value. Now we need to find the exact value of p. How do we figure this out? Giving any correct and to three significant figures. So we need to now use the logarithms to find the answer, right? So let's use the logarithms. We'll take it to the next page. So we are saying that the solution is 5 to the power of p is 6 over 5, correct? That is what the solution is. Since these two give you negative 2 and that give you negative 3, they are not valid. We want the exponential function to be greater than 0. And here we get a value which is positive. So we are solving for that value. So 5 to the power of p is 6 over this. We can actually take logarithms on both sides. So get p times log 5 is equal to log of 6 over 5. And from here, we can find the value of p as a ratio of the other two. So let me take it to the right side and then write down the answer. So we get the value of p as log of 6 by 5 over log of 5. Is that clear to you? So that becomes the value of p. So let's see, what do we get? Log of 6 divided by 5, and we have to divide this by log of 5. So what we get here is 0.11328. So that is what we get the value of p as, and we need to write the answer to how many significant figures? 3 significant figures. So let's round it. So this is equal to 0.113, and that is the value of p. So the answer here is that p is equal to 0.113. Is that clear to you? So that is how we are going to answer this particular question. I hope that makes sense. Let's look into what we've done just now. So the question given to us was with two factors. So we're given two factors, we need to find the third factor. So we found the third factor as 5x minus 6, correct? So we found the third factor as 5x minus 6. Now that factor gave us the solution of the final equation as x equals to 6 over 5. You get the idea. And what was x for us? X was 5 to the power of p. That was x. and x was 5 to the power of p. And then we used logarithms to solve the question. You see the steps involved. So that is how you're really going to solve a test question completely. I hope that you have understood the concept, and it also gives you an idea about how should you be preparing for this GCSE examinations. And this series will actually walk you through the best way of preparing for this particular exam. I hope that helps. Feel free to write your comment, share your views, and if you like and subscribe to my videos, that'd be great. Thanks for your time and all the best.